Everyone, thanks for joining the session on resilience in Azure. I'm Sujay Talasila, Senior Program Manager in Azure Cloud and Enterprise Division, and I'm going to co-present the session along with Raj Ganapati, Principal PM Manager in Azure Global Ecosystem Team. In this session, we are going to cover various resiliences offered by Azure. We'll start with the foundation design, how resiliency is built into Azure foundation, the logical and the physical infrastructure, how the redundancies are built in, and the key capabilities offered by Azure, the built-in Azure services that you can leverage to architect and deploy your applications in a resilient manner on Azure. And then towards the end, we will cover the resilient design patterns and best practices that you can leverage. So what are some of the main reasons that can cause outages? Apart from occasional hardware failures, one of the major reasons is the change. This happens in the cloud environment because fundamentally cloud is ever evolving. Anything that is getting deployed on Azure, you do it repeatedly. Like for example, any new features, any new capabilities that are getting rolled out, there is a constant change in software that is getting deployed on Azure. And this is fundamentally different when you compare with the way the applications are deployed and maintained in an on-prem environment. In the traditional way, you purchase hardware and then deploy your software on top of it, verify that everything works fine, and then leave it. But in the cloud, the advantage that you usually get is you get all the new capabilities every day. You're getting new changes deployed, and which are giving you new features. That means code is getting deployed continuously on Azure, and that can cause issues or downtime. And when it comes to building applications on Azure, it's a shared responsibility. So the platform inherently offers resiliency in the way the foundation is designed, and we also provide the built-in services such as Azure Backup, Azure Site Recovery for disaster recovery, and high availability using availability zones. But as the customer or developer, you need to ensure you leverage the existing capabilities offered by Azure and then leverage that for architecting your applications and deploying them to achieve true resilience and close to 100% SLA for your applications. Let's look at some of the foundational investments we do from Azure side for reliability. We break this into three parts. The first, how do we design our physical infrastructure, how do we design our logical infrastructure, and how do we deploy our servers on the physical machines and all of that. And then how do we operate our systems, how do we roll out updates, how do we deploy code, how do we operationalize all of that not to have any impact on your production applications. And then the last thing is about continuously observing and monitoring for any issues, any incidents, how do we react to them, how do we help you react to any issues and plan appropriately in case there is an impact on your application. Let's start with the design part. So Azure is very massive. We have customers all over the globe deploying their applications in multiple Azure regions. That means the applications spread across regions talk to each other, and that would require a high bandwidth connectivity between various regions. For that reason, we have our own cable network, more than 100,000 miles of land cable and subsea cable connecting the entire Azure region network. This will ensure that if there is any communication happening between your applications across regions, the data or the network transfer will not leave the Azure backbone. This will give you high bandwidth as well as security that your data will never leave outside the Microsoft boundary. And we also have more than 135 edge sites that are peered to the partner networks that will help you connect your data centers with Azure. And last but not the least, we have Azure running in more than 54 regions globally, and this is ever increasing. Like we'll keep adding more and more regions to our portfolio that helps you run your applications closer to your regions as well as spread across the globe. Coming to the network design aspect, this is very critical, and how we design our network in a redundant and highly available manner. Take the example of a region layout. If you have 3 availability zones, each has 2 data centers, one option of connecting these data centers is using crisscross connection where each DC is connected to another DC. But early, while we are designing Azure, we realized that having interconnectivity across all the data centers is not going to be easy to maintain, as well as it becomes fragile. So we took a different approach compared to what our competitors are doing. In every region, we deploy highly available regional network gateways, and all the DCs are connected via the regional network gateway. This ensures that the number of connections are limited. At the same time, you'll get low latency and high bandwidth connection between data centers. And these regional network gateways, again, are at least 2 of them in every region, situated miles apart. That will ensure there will be no impact even if one regional network gateway goes down. And from the outside connection perspective, the regional network gateways are connected to the edge networks that will help you connect to the internet or to your customer locations using the express route connections. And one thing about express route connections, even they come up with redundancy and high availability built in. When you purchase an express route connection, you get 2 devices so that you have inbuilt redundancy. What are some of the other aspects that we account for when we are designing our data centers? We have obvious redundancies built in, such as redundant power supply, the generators, the HVCs, all of the standard best practices while designing the data centers. And how do we deploy our servers on top of the hardware? We have Project Olympus is the open source project that Microsoft contributes to, which has high availability built in. And because it's an open source design, there are a lot of partner vendors that follow the same practices, and that will help us scale on new hardware that offers more GPUs and CPUs for high performance computing as well as general computing. So we can scale up and deploy faster on newer hardware without having any availability issues. Now, we realize that on Azure, storage is very important. Data is very important, and cloud is all about data and data computing. So we realize the importance of the customer data, and we go to any cost to ensure the customer data is always safe and secure. For example, the outage that happened in San Antonio in late last year, there were thunderstorms that impacted some of the hardware clusters, which included the storage clusters. So we took an extra time to recover what customers would have liked, just because we wanted to ensure there is zero data loss. That included steps like manually recovering some of the storage drives and attaching to the hardware clusters and bringing the data up. So during that outage, we ensured that there was not even a single byte of data loss for customers. And inherently, the storage offered by Azure has 3 copies of data residing within the data center. That will ensure even if 2 nodes go down, your data is always available. You can do reads and writes on that. And on top of that, we also offer role-based access control for you to control who is accessing the data, who is able to make modifications, and at the same time we have inbuilt policies that you can leverage to avoid any accidental data deletions. The second thing is about how we operate our systems, how do we deploy our code. And as you know, we constantly change our services and we introduce new features, new capabilities. That's one of the biggest advantages of running applications on a public cloud. And that means we have to ensure when we are rolling out any of these new features, we should not be impacting the customer production applications. And at the same time, we are also investing a lot in the machine learning technologies to predict any issues that might arise and proactively plan for remedying those issues. So one of the key processes that we follow when we are deploying code in Azure is a streamlined, safe deployment procedure. The whole objective of this is to ensure before the actual code gets rolled out into production data centers or regions and have your production applications running on it, any issues should be caught very early in the cycle. So the whole process starts left in the first step where our developers deploy the code and in their local systems and test and verify that everything runs fine. And then once the component testing is done, the code is pushed into staging environment. Staging environment is nothing but an isolated environment where all the dependent services are running and you can test the scenario end to end. And we also offer private previews for some of the interested customers to try the new features, new capabilities. And when all of this is done, we ensure that everything is running fine without any impact. And then we push the code next to EUAP regions. EUAP is Early User Access Program regions, and these regions have all the services that are running on Azure, and it has availability zone region, it has no availability zone region, it has all the geo pairs. So the code is put on this region for at least 24 hours to ensure everything runs fine. Even the customers who are accessing these EUAP regions have access to it and running their applications. And then the next phase is we push the code to diversity hardware platform, where in Azure we run the software on variety of hardware. So we have a mix of these hardware, and especially to test the fundamental pieces of storage code and the compute code, we run this on that platform to ensure it runs on all the variety of hardware and there are no issues. And then once this is done, we move to the pilot phase where we choose a lowly used Azure region and roll out the changes there, and post everything works fine, then it's moved to other regions. And the other key aspect is the paid regions concept in Azure, where one Azure region is paid to another Azure region and storage is geo-replicated. We ensure we roll out first in the primary region and then only roll out in the other region after at least waiting for 24 hours to see there are no potential issues. This ensures that if there are any issues, we can immediately roll back. So when it comes to ongoing maintenance activities on Azure, there are two types of activities. One is planned maintenance events, like, hey, we have to upgrade the host OS, and how do we do that without impacting your VMs, without causing reboot on your machines. And the other category of maintenance are unplanned ones. What if a hardware failure happens, or what if a hardware is predicted to fail? How do we react to that? There are two key capabilities that are available and we use to ensure there is no downtime for your virtual machines. In-place migration is a technology that we use to patch the underlying platform OS without impacting your VMs. The way it works is, as you can see at the bottom of the screen, if there are two nodes running your VMs, we pause the VMs for a few seconds, and we would like, the goal is to keep the pause time to less than 9 seconds, which is the TCP timeout period, and then within that duration, we patch the underlying hardware. And the next capability is live migration. This allows to move VMs from one node to another node without having any impact on your application. The way it works is, if you have VMs running on two nodes, node A and node B, and if you want to, for example, if Azure wants to decommission one of the nodes, say node B, and what we do is we start the live migration process and move the compute, the CPU, the RAM, and all the in-memory properties from node B to node A, and this is called the brownout period, where it's the VM on node B is still active, but it's continuously getting copied to the other node. And once this brownout period completes, the blackout period starts, which can last to about 2 or 3 seconds, where the VM is just moved from node B to node A. This live migration capability helps us to do any updates that will impact the hardware, and doing all of that without causing any downtime of the VMs. Apart from this, we also invest a lot in the artificial intelligence capabilities, the machine learning algorithms to define predictability models and predict any failures that can happen. Take an example of how we are leveraging the machine learning algorithms, a live incident that happened in October, on October 30th, 2018, where at about 1:59 p.m. We predicted if hardware storage node to go down. At around 2:10 p.m., we started live migration for all the VMs on that node to another node, and then the blackout period lasted for about 2 seconds, and then the hardware node was decommissioned. And the stress tests were run on that node, and by around 6 p.m. time, we figured out that the hardware had hit some failures, and we sent the hardware node for repair activity. And the last thing is how we continuously observe and ensure if there are any incidents, it won't impact your applications. We have Service Health dashboard where you can monitor the health of all Azure services, all the resources that you are using, if there are any potential issues that are impacting your services, and you get alerts for that. And we also have rich integration all the way into Azure Monitor, which helps you plug these alerts and events to any extensible incident management software such as ServiceNow, and you can configure it to send emails, SMSs, and all of that. So you don't have to keep monitoring this dashboard to know if there are any issues. All you have to do is just configure everything in the right way, that if you have any issue, you just get an email, and then you can appropriately react to that incident. Apart from the Azure Monitor integration and the way to get alerts, there is also programmatic capabilities available which you can leverage and ensure you have your application react to any upcoming maintenance activities. There is an Azure API endpoint available which you can continuously probe into and get information about upcoming activities such as platform initiated maintenance which might require reboot, and then you can appropriately design your application in such a way that when any of these events are going to happen, you can take proactive corrective actions and ensure the maintenance window doesn't impact your application. We have seen how we invested in the foundation to be resilient, how we designed our infrastructure, how we observe, how we monitor everything. And then we are going to talk about how you can build resilient applications on Azure. And I would like to invite Raz onto stage to talk more on this.
Thanks, Sujay. Good afternoon, everyone. So Sujay did cover the resilient foundation. Now, I'll be talking about the capabilities that Azure offers for you to build for highly available applications and how to ensure for disaster recovery protection and some of the architectural patterns that you could consider. Before I talk about the capabilities and the architecture, one thing that I want to call out is that resiliency comes at a cost, right? If you want to build for high availability, it means that you are investing more than 1x of your original application running cost, okay? And also, inherently, if you're talking about distributed computing, complexity is going to increase, okay? So therefore, the kind of resilience option or the pattern that you're going to choose should ideally be informed by the business criticality of the specific application, right? Not all applications require same level of availability or uptime, okay? The more you move up on the y-axis, the more it's going to get costly, and also the complexity is going to increase, right? The first thing that one should do as an exercise before picking a specific pattern is to understand the application's business requirements, which can be translated roughly into SLAs or SLOs, okay? That should let you know which pattern you're going to be using for your application deployment. So in order for you to think about the various capabilities that Azure offers, think of various failure modes that can happen in a cloud environment, okay? And any of these failures could potentially impact the availability of your applications, right? So therefore, assessing your application-specific requirements and then looking at the failure modes that you want to protect your application from is something that you need to think about as part of your system architecture, okay? In Azure, we are offering various capabilities and the flexibility for you as an app developer to determine what is the kind of availability that you're going to build your application for, right? The failure could be that a single node goes down, okay? This could be a hardware failure in Azure, that could potentially take down your virtual machine, right? The second is that within a given cluster, a cluster basically means 20 racks in Azure, typically, right? And each rack has about 40 physical machines, right? So it's about 800 different machines within a single cluster, right? So we have a capability which protects an entire rack getting impacted because of hardware failure or because of network failure. The next level of failure that could happen is an entire data center could go down, right? What happens to your application at that point of time is something that you need to think about, right? And then at the right extreme, a major disaster event could happen, and it could take down the entire Azure region, right? Is there a requirement for your application to architect for that kind of a scenario? And across all of these spectrum, you also need to think about how you're protecting your data through backup mechanisms, right? So if you talk about the solutions, there are still a lot of applications which are still running on single VM, which are probably not architected for being cloud native, right? One of the things that we recommend customers to think about or use is at least have premium storage built into it so that there are no disk level failures that can take down your application, right? That's not really a high availability pattern, but that's the least that one should be thinking about if you're running a VM-based, single VM-based application. The second is Azure offers availability sets, which protects from rack-level failures. I'll dive deep into each of these constructs subsequently. For data center level outage protection, we recommend availability zones. And for an entire region level failure, we recommend you to think about multi-region deployments, okay? In all of these cases, you're going to make sure that the data backup is taken care of, right? So the first construct that we have in Azure from a high availability perspective is availability sets, right? Availability sets has basically two properties. One is called fault domain, and the second is called update domain, right? Fault domain basically means a single rack within a cluster, which I just explained a few minutes ago, right? So when you create two virtual machines within an availability sets, and then say I want this to be distributed across two fault domains, Azure ensures that the VMs are placed across two different racks. So therefore, if an entire rack were to go down or a network outage were to happen at that rack level, your application should not face a downtime, right? That's the physical aspect of it. The second aspect, which is the update domain, is something that Azure makes sure that whenever there is a platform maintenance that Sujay just talked about, Azure platform ensure that no two update domains are updated at the same time, which means that even if one of the VMs that you are deployed in an availability sets were to get impacted because of a bad rollout or a planned maintenance event going haywire, your application availability should not be compromised, right? We offer 99.95% VM uptime SLA when you have your virtual machines in an availability set, okay? So if you were to think about architecting, this is the first pattern, right? Let's assume it's a 3-tier web application. You have the front end, and you have the business logic tier, and then you have the data tier. What we recommend you to make sure is that use availability sets across each of these tiers so that you have high availability across each of the tier, and you can make sure the uptime is guaranteed, okay? The patterns that I'm talking about here are heavily IaaS focused. The one thing that I want to call out, given the developer audience that we have here, these are the exact same patterns that Azure's PaaS services are using to offer the high availability that you will be getting. Let's say you're using web apps or service bus or event hubs or whatever that may be in terms of the higher level services. All of them at the bottommost layer use one or more of these patterns to offer you the SLA guarantee. Second construct, which we talked about, is something that can help you protect from an entire data center level failure, okay? We launched availability zones around about a year and a half ago. What it basically means that if you think about the hierarchy of the physical infrastructure in Azure, right? At the topmost, you have the cloud. Then you have geography. A geography is nothing but a data residency boundary. Let's take, for example, US is one or European Union is one, right? Azure offers multiple regions within a geography for you to run your applications for high availability and disaster recovery with data residency compliance that would be required, right? The next level is a region. A region is a collection of data centers within a given metropolitan area, right? Availability zones sits below a region, okay? Each availability zone is made up of one or more data centers. And in any given region, we have 3 availability zones, okay? These availability zones are separated by few kilometers, and each of them have independent power, networking, and cooling. So therefore, if one of the zones were to go down, let's say because of a flood or a power outage, the other 2 zones should not get impacted because of the same root cause, okay? So if you are using availability zones and deploying your application across multiple zones within a given region, you can ensure that if an entire data center were to go down, your application will still be running. And also it allows you for synchronous replication of data. So therefore, any quorum-based application you can run without having any impact to your performance or latency of that particular application, right? So this is the next level of protection that Azure offers, and customers can get will get 4 nines SLA when 2 or more virtual machines are deployed across 2 or more zones within a given region. If you go back to the same reference architecture that we showed on availability set, let's take the same 3-tier application. Here, what you're doing is, instead of putting the virtual machines in a single availability set within a given tier, you're going to ensure that, let's say there are 3 virtual machines for a web tier, you're going to place each one of them in 3 different zones. Therefore, if one of the zones were to go down, zone in the sense you could think about as a data center, right, the application should still be running, right? So we have a demo where we will be showcasing how this actually works, when one of the zone goes down. The next level of protection that one needs to think about is that, okay, what if an entire region were to go down, right? So in 2017, we had this major hurricane event, which led to a lot of floods in Houston area, right? That impacted about 60 square miles of area in Houston, right? Even if you were to use availability zones, it may not have protected if all those buildings were to be impacted by that particular flood, right? So therefore, we have the capability in terms of region pairs or multi-regions, and that is backed by Azure Site Recovery, if you're thinking about a built-in automated disaster recovery solution, right? So what it does is Azure Site Recovery asynchronously replicates the VM data from the primary region to your secondary region. And if an entire region were to go down, you can invoke your disaster recovery strategy and bring up the secondary instance, right? That is at the IaaS layer, right? If you want to think about, let's say, at the PaaS layer, you could potentially run multi-region active-active deployments where there is no data synchronization required. If data synchronization is required, what you could do is you could run active-passive, and if one region were to go down, you could then fail over to the secondary region. So extending the same architecture that we have been seeing, in this case, what you're doing is that you have your application deployed across 3 availability zones in the primary region, and you have the exact same architecture in the other region with 3 availability zones, and you've connected up with Traffic Manager, for example, if you want to run active-active, and you've configured it with Azure Site Recovery. And what Azure Site Recovery does is it continuously replicates the stateful virtual machines from the primary region to the secondary region. And in all of these cases, you want to make sure that you're backing up your data in the region so that in case you have to go back to a point-in-time recovery of your data, you are able to recover that, right? So there are 3 different patterns that I talked about, just to summarize, right? You could think about running within an availability sets, which offers you 99.95 SLA. You can run for high availability with availability zones within a single region, which offers you 99.99% SLA. And then the third is you're architecting for high availability and disaster recovery, right? So I'm going to now hand it over back to Sujay to show this in action with a demo.
Thanks, Raj. I have a simple 2-tier application here running on 3 Azure virtual machines for the front end deployed across the 3 availability zones in East US 2 region. And for the database tier, similarly, the 2 database VMs are deployed across 2 different zones within East US 2. And I have a simple website running on those VMs. And as you can see, if I keep refreshing it, the VM in each of the zone is servicing the request in a round robin fashion. Where I keep refreshing it, you can see that the VM in zone 3, VM in zone 1, VM in zone 2, zone 3. It continuously services your request. So this way, your application is load balanced across all the availability zones, which means if something were to happen in one of the availability zones, your application VMs in the other availability zones will still continue to service these requests. And let's see in action what would happen if I bring two of these VMs down in zone 1 and zone 2. I'm going to stop these VMs just to simulate a failure scenario, and this will take about like 15-20 seconds for the VMs to go down, and then see what happens if I keep refreshing the website. So as you can see, the machines in zone 1 and zone 2 were shut down, and now if I try to refresh, the VM in zone 3 is servicing the request. So this way, even if any VM in one of the zone goes down, your application will continue to work. Now, what happens if I even bring down the third VM, which is a region failure scenario where all the zones were impacted and all your entire application VMs are not running anymore? The machine is still shutting down, and you can see that your website will go down because all the machines that are servicing the requests are not alive anymore. And what I have done is, for this application, I have pre-configured Azure Site Recovery replication for all the virtual machines, and I also created a recovery plan to orchestrate the entire failover of the application. So what I'll do is quickly invoke failover activity, the test simulation for a DR drill for your application, and then within about 8 to 9 minutes, your application should be up and running in the other region. Now you can see that the website that was earlier active is active no more, and the application failover has been initiated to the secondary region, and it should come live soon. While we wait for the application to come up, let me show you how simple it is to configure disaster recovery solution for your Azure virtual machines. So this is the familiar Azure portal dashboard for your Azure VM. You have an option to configure disaster recovery for the virtual machines. It's very simple. You just click on disaster recovery and you get an option to pick the target region of your choice. As you can see, you can pick any region within the US geographic boundary as your target region. And then Azure Site Recovery reads your source machine configuration and automatically populates the target configuration for your VM. It reads the source resource group, what should be the target resource group, the target virtual network, all of this is automatically defaulted based on your source configuration. And it also offers flexibility for you to define your own virtual network, your own resource group. All you have to do is review these settings, confirm that everything is fine, and then just start replication on your machine. So the entire replication process will take about 2 to 3 hours for the initial sync to complete, and once that is done, you can initiate failover activity or a DR drill failover anytime that you want. Now, you have seen how you can enable replication for your Azure virtual machines, but it's not enough to just enable VM level replication and expect the application to come up. For that, we have an advanced capability called recovery plan in Azure Site Recovery that lets you orchestrate the entire failover sequence for your application. So for example, in the two-tier application that I just showed you in the demo, it had 2 SQL database machines and 3 front-end machines. So in any application environment, it's important for the database to come up first, even before your application tier VMs can come. So you can do all of that in ASR recovery plan. You can create grouping, sequencing, grouping of machines, all of that to ensure everything as part of the failover activity happens in the right sequence so that there is no application dependency failures. And apart from that, we also have rich integration with Azure automation runbooks that can let you run any automation script that you want as part of the recovery process. Compare this with the traditional disaster recovery solutions you might have seen, where you will have a handbook of, hey, these are the sequence of steps you need to do on a disaster day, and someone has to manually run a particular script, verify something. So all of this activity is error prone. What we have done with the recovery plan capability is you can pre-create the entire sequence of recovery, and that will ensure you can fail over your entire application with one click. You don't have to worry about running a script, manually checking something, all of that. You can have a recovery plan pre-created, and then you can just keep it ready by testing it well ahead of time. When the actual disaster incident happens, all you have to do is just click failover on the recovery plan, and that's it. You have your application up and running in the other region within a few minutes. And we have customers who have implemented the recovery plan DR solution for their complex applications such as SAP and SharePoint, and they get recovery time objective, the amount of time taken for the application to recover within less than 30 minutes. So you can recover an entire application such as SAP in other region within less than 30 minutes once you have your recovery plan pre-created and tested. So in this demo scenario, what I wanted is on the VMs that are coming up in the target region, there needs to be a load balancer configured automatically. So for that, I have added a script which does the configuration of load balancer across all the VMs automatically. You don't have to do anything manually or run a script of your own. This is how you can leverage the recovery plan capabilities to reduce the recovery time for your applications. Then let me switch the topic a bit onto how can you recover if in case there are accidental deletions on your data or the virtual machines. So for all the machines that I showed you which are hosting the two-tier web application, I have enabled backup on all the VMs. And if you have any incident such as, hey, you have accidentally deleted a file, or by mistake someone deleted your machine, or there is a corruption in your application that impacted your VM, or the extreme case could be someone did a ransomware attack on your machines and your application is impacted, and you want to ensure you can recover from that. All you have to do is go to the backup, and because you have backup, the Azure backup service pre-configured on your VM, or you can just simply restore a VM. Restoring the VM is very simple. You can just click the recovery point, which can be anywhere up to 24 hours old, and then you have the option to either recover the disks or recover the entire virtual machine. You can just this recovering VM activity will be done in about 10 minutes, and you should have your VM up and running in about 10 minutes, and you can use this to do recover any for any issues like file deletion or VM getting corrupted, application getting corrupted. Let me see if the failover that I initiated for the application is complete. Yep. So you can see that whatever failover I have initiated about 10 minutes back for the application that was running in East US 2 and the replication configured to Central US, now the application is up and running fine in Central US. So you can see that recovery of your entire application is very simple. Like a simple application like what I have shown, I recovered in less than 10 minutes. So this is all it takes if something happens and the region goes down for you to recover your entire application. So in this session we have seen how Azure Foundation is designed to be highly resilient and how we operate, how we deploy our code, how we continuously observe for any issues and how do we react to them, how do we help you react to any issues, and then also cover the critical capabilities and built-in services that are offered by Azure to give you high availability, disaster recovery and backup for your applications. And you can leverage all of this to deploy, architect, deploy and run your applications in a resilient manner on Azure. We have some of the additional resources that you can leverage with respect to best practices, various resilience offerings that we have on Azure, how you can construct highly available applications, and there are a lot of resources available out there which you can leverage while developing your applications. With this, I'll open the floor up for any questions.
So the question was, if you are running an application on AKS, which portions are taken care of, right? So AKS currently is in the process of supporting availability zones, right? So the underlying nodes that host the containers will be highly available when AKS supports availability zones from a data center level failures. Currently, what it does is it uses availability sets underneath so that it can protect from rack level failure. Did I answer your question? Okay.
Yeah, are there any tools or techniques for simulating these DR scenarios besides just turning things off in the portal?
Yeah, that's a good question. So there are open source fault injection chaos monkey tools that you can leverage. Maybe we can connect after the session. I can point you to a couple of tools that I would recommend. And also, we do conduct internally the EUAP region that Sujay mentioned as part of the safe deployment process. We do conduct disaster recovery drills for Azure's platform resiliency validation. In certain cases, in certain scenarios, when the customers are interested to participate in those drills, we can onboard them to co-participate in those drills. So we can talk about it, and if you're interested, we can take it forward from there. Yep. Do you have a question? So the question is, if there is a large VM like M-Series, does ASR support it?
So we support the limits that we have are on each disk we support up to 10 megabytes per second. So as long as the data change rate on the VMs per disk is within the 10 megabytes per second limit, yes, we do support. And we are also working on improving the data change rate limits, and we are going to support 20 megabytes per second in the next 3 months. So as long as any VM, as long as it is within the supported limits of ASR, yeah, it just works. It doesn't matter whether it's M series or any of the higher end configurations.
Okay. Thank you. Thanks again for attending the session.
Thank you.